Back to another video dedicated to physics. We gotta apply the concept of gas states and concept of ideal gas in normal conditions in order to undertake the first problem. Okay, it's all about thermal physics. Hope you remember the equation of gas states. Here I'll just quick remind you. So PV equals nu RT, where nu number of moles. So number of moles. You might have an equivalent writing this formula in terms of mass over molar mass, RT. So R is the constant, 8.31, so that's R. And basically equation of gas state connects micro parameters like pressure, volume, and temperature. Okay, so that was quick reminding, and let's have a look at the problem. So here is the problem. Pause the video, try to do by your own. I just give some comments to that first. We have a vessel of given volume at temperature. So here is the leakage of the gas. You need to find change in the pressure in the vessel after 25 grams of gas has been released, okay, due to the leakage. Also make sure you understand that what normal conditions are. Basically normal atmospheric pressure, which is around 10 to the power 5 pascals, and normal temperature 273 kelvins. All right, pause the video, try to do by your own. It's not really a tricky one, so everyone can do using just basic knowledge in thermal physics related to gas states. Okay, and let's have a look at my explanation. So alright, as I like to describe, I use the process way. So here is the state 1 and here is the state 2. And here is the process of leakage. So that's how normally you need to start off solving any problem related to the process that takes place with your gas, with your system. So that's definitely because we're set using the model of ideal gas and isothermic process. We can say that parameters T is not changing. So the original temperature T0, but I mark as T because I will use T0 for normal conditions. Okay, so temperature remains the same. Okay, and this temperature is 10 Celsius, but I would convert into degrees. It's going to be plus 273. So it's going to be, sorry, I will convert into, my bad. I'll convert into kelvins. It's going to be 283 kelvins here. So it remains the same. So we have isothermic process. And what about other parameters? Definitely pressure, which is from, let's mark the first state as state 1. And here is state 2 is better. So that means P1. And here is P2. Pressure is changing because we need to find, obviously, change in pressure. And so what about volume? Volume stays the same because we still have the same vessel. So that means V1 and V1 is here. So volume is not changing. All right. Here is the process of leakage. So here is the leakage. That's the process that takes place. It means that change in mass takes place here with our gas system. So that means we go in and number of moles is changing. So that means mass 1, and here we will observe mass 2. Okay, so what we can do, we can just write two gas states for P1 for initial volume, for initial state. So we'll write in this way, P1 V1 equals to molar mass, obviously not changing, RT. So temperature is not changing as well. So what about state 2? We will have new pressure, the same volume, new mass M2, and the same other, the rest of the formula. Okay, so that's what we have right now. So we have gas of state formula for state 1 and for state 2 respectively. So what we can do, if we express change in pressure, so basically subtract from formula 2 formula 1, So basically what we're going to do is to make this difference, and we'll get the following. So change in pressure times the original volume, V1, which is 20 liters in our case, so we can mark V1 as 20 liters, stays the same, 20 liters. And on the right side, what we'll have change in mass over molar mass and RT, all right? That's going to be constant. So up to now, we arrived to that. And what we need to express? We need to express change in the pressure. So here, from here, we can simply put that and write so that change in pressure is simply change in mass over molar mass, RT, and over V1 as well. So V1 is here. Okay, so what we need to establish right now. So from here, we arrive to this one. Okay, so what we need to know, I just highlight the parameters that we need to define. So we need to define basically molar mass. Always better to maybe express R over molar mass. How we can do that? We're given normal atmospheric pressure and temperature 273, and we are given a density. All right, so we have density, we can operate with that. What we can do, we can simply write normal conditions. So using normal condition for the same gas, normal conditions, we can write the following. P, 0, normal pressure, volume, let's take the same volume, equals to, no matter which volume you take, so maybe you'll take another volume, but mass over molar mass we can express as density times volume over the molar mass, and times the rest part RT. In this case, we'll use RT 0, okay? Because we're going to use normal conditions. All right, so what we need to do, volume will be cancelled, so we can cancel volumes here, and we'll let with R over molar mass that we need to define. So from there, we can define R over molar mass. So let's have a look. R over molar mass is simply P0 over T0 and over density. All right, so we simply express that, and right now we can plug instead of this part. So just highlight so that we can put instead of R over molar mass, and right now I'm gonna do that. So change in pressure, in our case, change in pressure will be change in mass over volume V1. So R over M over molar mass should look like P0 times T and over T0, and density here rho. All right, so where rho is the density, so this is the density. Make sure you understand that. So we're given this density, we're given all other parameters, so now we can just simply plug that. Okay, so let's plug into the formula, and let's just make some final calculations here. All right, so change in pressure is going to be equal to change in mass, 25 grams. So sometimes you need to convert into, SI units. Obviously, you need to convert into kgs, but I understand that change in mass over density rho, which is also given in grams, I will stay with the same units as well. For the volume, I will stay with liters because we're given density in grams per liters. So it's going to be 25 times 10 to the power 5, that's the pressure, times temperature, which is in our case 283, that was 10 degrees, and over the volume, which is 20 liters, and times density 1.2 n times normal conditions temperature 273. So right, if you calculate that, what I'll get change in pressure is around 0.72 to 1 decimal place times 10 to the power 5 pascals. All right, if you like, you can convert into atmosphere, but you understand it's simply divided by 10 to the power 5. So change in pressure is going to be around 0.72 atmospheres. All right, so 0.72. So hope you understand. So we use the idea of the process. Here is the complete solution for that. It's sort of easy medium level. Hope you understand. We use several formulas. It might be useful also for A-level IB students, especially in paper 2 and IB for H level. So hope you understand that, hope you like that, and we'll consider several more problems in next videos. Don't forget to subscribe if you're new here. You were on Physics with Daniel Dallas. See you next time.